Cryptography is the science of hiding information using secret codes. Although there's evidence of cryptography dating back to the ancient Egyptians, the rise of computer technology has led to codes that no human could break without the aid of a computer. In this lesson, you'll learn about how cryptography works in C# and prepare some information to be encrypted. You will carry out the actual encryption in Lesson 3.2. To begin, open the Textland project from your Sample Files folder. And open encryption.aspx in Design View. The text box on this page contains some military orders from World War II. In 1944, the Army would have had to encrypt and decrypt these orders by hand. But when this page is complete, it will be able to encrypt and decrypt the orders in less than a second. Next, open the code behind file of encryption.aspx. And add the following using lines to the top of the page. Using system.security.cryptography, using system.io, and using system.text. System.security.cryptography contains the .NET Framework's encryption algorithms. System.io contains the stream objects that you'll need for encryption. And system.text contains methods that you'll need to convert text into binary data. Next, you're going to add some code to prepare the text for encryption. Add the following code to the button encrypt click event handler. Bytes to encrypt equals encoding dot utf8 dot getBytes textbox encryption dot text. This code converts the contents of the text box encryption control into a byte array, representing binary data. You learned about byte arrays in Lesson 2.4. Encryption in C# always works with binary data, so you'll have to convert anything that you need to encrypt into a byte array. In order to save string data as binary data, it must be encoded. Different encoding standards will produce different binary data. In this lesson, you're encoding the text with the UTF-8 standard. Every encoding standard is capable of handling standard English letters and numbers, as well as most symbols. The differences between encoding standards appear when working with different languages, as some characters may not be supported by every encoding standard. Now add the following code on the next line. String encryption key equals textbox encryption key dot text dot pad write 32 byte encryption key equals encoding.utf8.getBytes string encryption key. An encryption key is always needed when encrypting data, and will be needed in order to decrypt the information again. The AES algorithm that you're going to use requires a 32-byte encryption key. So this code uses the pad write method to pad the text if the user has entered a key that is less than 32 characters long. The last thing that you'll need in order to encrypt is an initialization vector. Add an initialization vector by adding the following property outside any event handlers. Byte initialization vector equals new byte 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The AES encryption standard requires an initialization vector as well as an encryption key. The initialization vector is not unlike a secondary encryption key, as its presence makes the encryption harder to crack. If you use an encryption standard that requires initialization vectors, you will need to keep a record of the initialization vector, as it will be needed along with the encryption key in order to decrypt the data. It's not recommended to reuse initialization vectors. Somebody trying to crack your encryption can detect patterns from repeated initialization vectors. This may enable them to crack your encryption. The initialization vector that I've used in this example is just about the worst vector that you could possibly use in a real-world situation, as it can be easily guessed. You're going to use your binary data, encryption key, and initialization vector to encrypt the military orders in the next lesson. That's lesson 3.2. Close Visual Studio now, saving your changes if prompted. You've now completed lesson 3.1. Understand cryptography and prepare data for encryption.